Every year, thousands of peacocks are bred in China, generating billions of dollars in revenue. These birds are not just a lavish addition to estates, they are a true gold mine. Their feathers sell for dozens of dollars per piece, and their meat is served in luxury restaurants for hundreds. But did you know that peacocks are also bred for cosmetics and traditional medicine? How did China turn these exotic birds into a global business? Let's find out. At first glance, a peacock seems like nothing more than a decorative bird. However, China's peacock breeding industry has long moved beyond simple admiration for their beauty. Farmers supply peacocks to parks, reserves, hotels, high-end restaurants, and even private estates. The price of a single bird can range from $100 to $1,000, depending on the breed and coloration. Albino peacocks and rare varieties with unusual color patterns are especially sought after. Peacock feathers are widely used in high fashion, theater productions, and jewelry making. Long, iridescent feathers sell for dozens of dollars each, while exclusive sets can fetch hundreds. Chinese farmers carefully collect molted feathers, creating an entire market around them. While eating peacock meat is considered unacceptable in many cultures, in China, it is served as a gourmet delicacy in high-end restaurants. It is said to resemble pheasant, but with a more tender taste. The price of a portion of peacock meat can range from $50 to $100. Peacock fat and extracts are used in traditional Chinese medicine and cosmetics. These are believed to have rejuvenating and healing properties, making peacocks yet another lucrative source of income for farmers. At large farms, tourists can not only observe the birds, but also feed them, take stunning photos, or even purchase a feather as a souvenir. This business attracts additional investments and increases the value of peacock farming. It seems these birds generate profit with every aspect of their existence. Peacocks have been bred for thousands of years, fascinating people since the times of ancient Egypt, Greece, and China. It is believed that the first domesticated peacocks appeared in India, where they were revered as sacred birds. They were later transported to Persia and eventually to Europe. The ancient Romans not only admired peacocks, but also served them as a banquet delicacy. However, the real boom in peacock farming began in China during the 20th century. Farmers quickly realized that these birds were not just decorative, but also highly profitable. Before the coronavirus outbreak in the year 2020, China had approximately 20,000 farms breeding various wild animals, including peacocks. This industry generated around $74 billion and provided jobs for 14 million people. After the outbreak, the Chinese government shut down these farms due to concerns about virus transmission from wild animals to humans. The size of a peacock farm can vary significantly depending on the scale of production and breeding purposes. Small private farms may occupy just a few thousand square feet, while large commercial facilities span multiple acres. The ideal farm size depends on ensuring the birds have enough space for comfortable living and breeding, while efficiently organizing farm infrastructure. Peacocks require ample space to move freely and display their magnificent tails. The recommended area per bird is approximately 100 to 160 square feet. This means that a farm with 100 peacocks would need at least 11,000 to 16,000 square feet of open space. Additionally, space must be allocated for shelters, feeders, incubators, and other farm structures. Choosing a location also depends on climate conditions, access to feed and water, and proximity to sales markets. In regions with mild climates, peacocks can be kept outdoors for most of the year, reducing shelter construction costs. However, in areas with cold winters, farmers must provide heated enclosures, increasing the farm's overall footprint. Everything starts with eggs. Wild peacocks lay up to 20 eggs per season, but on farms, with proper care and a balanced diet, a single female can produce up to 40 eggs. The eggs are collected and placed in incubators, special machines maintaining a temperature of 99.5 degrees Fahrenheit and humidity around 60%. Under these conditions, embryos develop, and in 27 to 30 days, the first chicks hatch. Newborn peacock chicks are highly sensitive to temperature, so they are kept in heated enclosures at temperatures ranging from 85 to 95 degrees Fahrenheit during their first weeks. They are fed finely chopped boiled eggs, millet, and special protein and vitamin-rich feeds. By 1.5 months, they begin to grow faster and are transferred to larger enclosures. It is crucial to provide at least 3 square feet per bird. Otherwise, they may start competing for space and food. Peacocks grow slowly. It takes 2 to 3 years for them to reach their full size and develop their spectacular plumage. During this time, farmers carefully monitor their diet, living conditions, and health. The birds are fed grain mixtures, greens, insects, and protein supplements. An adult peacock consumes slightly more than 1 pound of feed per day. Although peacocks are quite resilient, they can suffer from viral and bacterial infections. Farmers vaccinate them and conduct regular feather inspections. Checking feather quality is a crucial aspect of peacock care, especially on farms where they are bred for sale or decorative purposes. Farmers or veterinarians examine feathers for damage, molting, parasites, and overall health. They check for broken, dull, or missing feathers. The brightness and uniformity of the coloration indicate the bird's well-being. Feathers and skin are also inspected for mites, lice, or fungal infections. The tail feathers of males receive special attention, as they are the primary decorative feature. Farmers carefully spread them out to assess length and integrity, ensuring molting occurs naturally. Peacocks molt annually, and this process lasts for 2 to 3 months. If necessary, birds are bathed in special parasite treatments, or their feathers are conditioned with nourishing agents. When peacocks reach the desired age, they are categorized based on purpose. The most beautiful and healthy males and females are sold for decorative purposes. Some birds are kept on farms to continue breeding. Every year, peacocks shed their magnificent feathers, which farmers collect for sale. These feathers are used in fashion, decor, and art. Of course, some birds are also processed for meat. Peacock meat is dark and tender, somewhat similar to pheasant, but with a richer aroma. It is often prepared with citrus fruits, wine, or spices to enhance its refined flavor. Despite being exotic, peacock meat remains a niche product, but for farmers, it is yet another revenue stream. The purchase of peacock carcasses is a niche yet stable market. Restaurants and hotels place regular orders, though in limited quantities. Private customers usually buy peacock meat for special occasions. Who buys peacocks for consumption? High-end restaurants, especially in China, India, and the Middle Eastern countries. Chefs order peacock meat for exclusive dishes served in VIP rooms or at special events. Wellness centers. Some Asian practices believe peacock meat has medicinal properties. It may be recommended for boosting immunity or as an energy-rich food. Luxury hotels. Large resort complexes catering to affluent tourists may include peacock dishes on their menus. As for feathers, peacocks shed their plumage annually, allowing farmers to collect up to 200 long feathers per bird without harming them. This is a distinct business sector, as peacock feathers are used in high fashion for clothing and accessories, stage costumes, jewelry making, interior decoration, and cultural rituals. Farms export feathers worldwide, generating a significant portion of their revenue. Peacocks are sold through zoological farms, online stores, and specialized auctions. Chinese farmers have mastered promoting their products through social media and even use live streams to showcase their birds to buyers. Peacock exports from China are growing rapidly. The highest demand comes from the Arabian countries, the United States, India, and Europe. Peacock feathers are transported worldwide using various methods depending on volume and destination. Feathers are either hand-plucked or removed with special tools, then carefully packaged to prevent damage. They are primarily collected during natural molting when the feathers fall off on their own. Feathers are meticulously packed in special boxes or bags to prevent bending or breaking during transport. Soft materials such as paper or fabric are often used for extra protection. Thanks to modern logistics systems, peacock feathers can be shipped by sea, air, or rail. Large shipments are usually transported by sea freight, while air freight is used for faster deliveries. Since peacock feathers may be subject to export and import regulations, proper documentation and certification are essential for customs clearance. Specialized logistics companies with experience handling delicate cargo typically manage large-scale or international shipments. Imagine a machine that can withstand the blast of a high-explosive device, endure fire from automatic weapons, and keep rolling even with shot-through tires. This is the legendary Hummer, designed for the most dangerous missions. From operations in the Persian Gulf to modern combat zones, over 280,000 armored Hummer vehicles have become an essential part of the United States Army. How do these machines go through their testing? Which materials protect the crew? And why do they produce 70 of them per day? Let us find out. To understand why the Hummer became synonymous with invincibility, one should first look back at its history. In the 1980s, the American automobile company called A.M. General unveiled a modified Hummer that was initially developed for the civilian market. However, the troops quickly recognized its advantages for modern warfare, especially on the front lines, where soldier protection is paramount, and armored vehicles became critically important for safety. A true breakthrough came after the Hummer became the main transport vehicle for the United States military during operations in the Persian Gulf at the beginning of the 1990s. Since the year 1893, over 280,000 Hummer units have been manufactured. But how can one ensure that this off-roader not only endures harsh conditions, but also provides protection in the most hazardous situations? What exactly sets the military armored Hummer apart from civilian models? Let us see how the armored components are constructed to turn these vehicles into a genuine steel shield on wheels. Military Hummer vehicles use specialized armor materials, including composite armor that combines steel plates with ceramic inserts. These materials can withstand shots from a variety of weapons, including automatic rifles and sniper rifles. Moreover, by incorporating composites, these vehicles are not only armored, but also relatively light for their size. The production rate is around 70 vehicles per day. A key structural element of the armored Hummer is the concept of plus armor. This means that multiple layers of protection are added onto the vehicle, enabling maximum defense in a wide range of combat scenarios. There are also additional design modifications, such as reinforced suspension and strengthened tires, allowing the vehicle to keep moving even if one of the tires has been damaged. Another important aspect is the strengthened floor and roof. In military Hummer vehicles, the floor is structurally protected against blasts. Special materials are used to absorb the shockwave, which reduces risk to the crew if the vehicle encounters a minefield or an explosive device. However, armor is only one part of the overall safety level. Each high-mobility multi-purpose wheeled vehicle, commonly known as the Hummer, consists of over 5,000 parts. Combat Hummer vehicles must not only be protected, they must also be real beasts capable of moving through absolutely any conditions. How is this kind of mobility achieved? In order to preserve high off-road capability and endurance, military Hummer models are equipped with a powerful diesel engine. This engine can generate substantial power that lets the vehicle easily travel through desert sands or mountainous routes, even if there is no road at all. A specialized transmission and adapted rear wheels ensure constant stability in the most extreme conditions. Many modern military Hummer vehicles integrate intelligent control systems that allow the engine and transmission to adapt to the terrain. This significantly boosts maneuverability and endurance during large-scale strategic movements. Armored versions receive steel that is half an inch thick, along with bullet-resistant glass that is 1.5 inches thick. Besides armor, electronic safety systems are vital, such as sensors that detect mines and explosive devices, along with systems designed to remain fire-resistant. They add another layer of protection for the crew, which is particularly critical in combat situations. What else is worth mentioning when talking about armored Hummer vehicles? There are several technical considerations to bear in mind. Military Hummer versions often feature specialized camouflage coatings that help them blend into the environment. This is crucial for enhancing survivability on the battlefield, where every detail can make a difference. Interestingly, the Hummer is not a static vehicle. Its design allows modifications based on mission needs. These can include additional weapon systems, medical equipment, or other specialized modules, depending on the task at hand. A military Hummer can carry up to 2,500 pounds of cargo or tow up to 7,500 pounds. Producing armored Hummer vehicles is a complex and lengthy process that demands highly skilled engineers and advanced technology. Everything starts with meticulous planning. Engineers account for every aspect, from improved mechanical components to resilience during blasts. Multiple prototypes are built, each undergoing a battery of tests. They are dropped from heights, fired upon, and examined for endurance in different conditions. Previously, AM General, the company that originally created the legendary Humvee, was in charge of production. However, in the year 2020, the license to manufacture new military vehicles was granted to Oshkosh Defense. As a result, combat Hummer vehicles are gradually being replaced by the Joint Light Tactical Vehicle, a more modern armored off-road vehicle. Therefore, military and civilian versions are produced separately, using different factories, technologies, and even materials. The body and armored panels are cut using laser or plasma machines, and then they are welded by robots and highly qualified specialists. Precision is crucial, because all seams must be airtight to enhance blast resistance. The Hummer is built on a robust steel frame, designed to withstand high loads. The chassis and engine are assembled separately, then tested for functionality. Only after that are they joined with the body. Once the main parts are put together, the vehicle is fitted with armored panels and additional protection. This stage is time-consuming because every component must be installed with the utmost precision. The interior of a military Hummer is nothing like that of a civilian vehicle. Everything is dedicated to functionality. Some models have air conditioning, which is essential in desert conditions. After assembly, the vehicle is painted with special scratch and corrosion-resistant paints. Several options are employed: desert camouflage for sandy regions, woodland or urban camouflage for the respective environments, and anti-radar coating to reduce visibility on radar systems. This is no ordinary paint. It is formulated to withstand heat, freezing temperatures, and the impact of blasts. The high-mobility multi-purpose wheeled vehicle is not produced in the same way as mass-market civilian cars. It is manufactured in relatively small batches, so fully automated production is impractical. At the same time, certain processes, such as welding and painting, are streamlined by a conveyor system for speed and consistency. Each high-mobility multi-purpose wheeled vehicle is equipped with a 396 cubic inch diesel engine that outputs 190 horsepower. This powerful diesel engine is engineered to operate under extreme conditions. The transmission is a 4-speed automatic adapted for off-road use. The vehicle has permanent 4-wheel drive and automatic differential locks. It accelerates to 37 miles per hour in approximately 17 seconds. It is slow, but speed is not the main goal for the military. For military transport, the priorities are off-road performance, reliability, and endurance. The high-mobility multi-purpose wheeled vehicle is not designed for swift maneuvers, but for traveling over any type of terrain. It has a high ground clearance of 16 inches, which allows it to clear rocks, ditches, and logs. Full-time 4-wheel drive and differential locks prevent it from getting stuck in mud or sand. The engine and fuel system are protected to withstand fire and blasts. There is minimal onboard electronics, meaning fewer things can break down in the field. It can continue moving on punctured tires. Special inserts allow driving even after the tire has been hit by a bullet. Its payload capacity allows transporting ammunition, injured personnel, and weapons ranging from machine guns to anti-missile systems. It may not be the fastest ride, but it will get you where others simply cannot go. The standard military high-mobility multi-purpose wheeled vehicle initially did not have armor, but since the year 2000, most models have received protection against small arms fire and shrapnel. Configurations vary, from soft body transport versions to the most widespread ones, capable of withstanding a high explosive device blast of up to 13 pounds. There are models with protection systems against chemical, biological, and nuclear weapons. Assembling a single high-mobility multi-purpose wheeled vehicle takes from 3 to 5 days, depending on the armor. At the AM General facility, where they build the high-mobility multi-purpose wheeled vehicle, there can be up to 3,000 workers in one workshop. However, only about 25 or 30 individuals work on assembling a specific vehicle at any given time. These include welders, mechanics, electricians, and armor specialists, each carrying out their tasks at each stage of the production line. The more complex the version, the more time and personnel are required. Before they are shipped, all high-mobility multi-purpose wheeled vehicles undergo 310 miles of test trials across off-road terrain, water, and dust. You already know how the Hummer is painted, but allow me to elaborate on the special matte paint known as chemical agent-resistant coating, which has several important properties. It does not reflect infrared light, making it harder to detect the vehicle with thermal imaging and night vision equipment. It resists chemical attacks. Its formulation makes it easier to wash off hazardous substances following chemical contamination. It withstands scratches and corrosion, enduring impacts from branches, sand, rain, sun, and aggressive liquids. The matte finish eliminates glare, which is critical for battlefield camouflage. The painting process involves multiple layers that are applied to the aluminum body and armored panels. Every single day, more than 20 million banknotes are destroyed in the United States. That is a mountain of money that could reach the sky. But what exactly happens to them? Are they burned, shredded, or maybe turned into something completely unexpected? US dollars have their own life cycle, and their disposal is a high-security operation involving armored trucks, strict inspections, and secret routes. How do old banknotes disappear forever? And is there any way to save them? Let's find out. The dollar as a currency has a fascinating history. It all began in the mid-17th century. The first dollars appeared in the New England colonies in the year 1690, at a time when the United States did not yet have a unified national currency. Back then, the colonies issued their own money, and one of these was the so-called paper dollar. However, the true dollar as we know it today emerged later, in the year 1792, when the United States Congress passed the Coinage Act. This was the country's first attempt to introduce a single currency, establishing the dollar standard based on a silver coin. The dollar quickly became the main currency for trade and wealth accumulation, as the nation sought to create a stable and accessible monetary system that would support its economy and commercial ties. Today, the dollar has evolved into one of the world's leading currencies, used in international transactions across the globe. The idea of disposing of old banknotes arose at the beginning of modern financial systems, especially when currencies started to become standardized and central banks began managing the money supply. In other words, the process of removing worn-out dollars started as soon as money became a stable and regulated instrument, though it was not officially systematized until much later. The concept of destroying damaged money first appeared in Great Britain during the 19th century, when the British government realized that allowing worn-out banknotes or coins to remain in circulation reduced the overall value of the currency. However, the systematic destruction of money, as it is done today, only became possible with advancements in modern financial systems and technology. In the United States, the first efforts to manage old and worn-out dollars began in the mid-19th century, when the first central authorities responsible for currency emerged, and money became a key instrument of the national economy. In the year 1861, when the United States first introduced federal paper money, known as greenbacks, the need arose to organize their circulation, including their disposal. The official process of destroying old dollars was established by the Federal Reserve after its creation in the year 1913. The Federal Reserve became the primary institution responsible for regulating the money supply, including removing old banknotes from circulation. The idea of destroying old banknotes was first introduced by central banks, which discovered that worn-out and damaged money not only harmed the image of a national currency, but could also create economic problems. If old banknotes remained in circulation, It could destabilize the monetary system, increase the risk of counterfeiting, and even affect inflation rates. To prevent this, the Federal Reserve established a clear policy outlining when and how banknotes should be removed from circulation. This became an essential part of maintaining economic stability. So, what exactly happens to all the money that can no longer be used and that no one wants to see anymore? Are they just burned? Well, not exactly. Disposing of US dollars is a complex process that follows a highly regulated system, ensuring both destruction and security. Here's how it works. First of all, when money is removed from circulation, whether it is declared damaged or obsolete, it does not simply get thrown in the trash. Everything goes through the United States Federal Reserve System, which manages the issuance and renewal of dollars. They collect old banknotes and send them to specialized facilities for further disposal. When you or someone else brings damaged or worn-out dollars to a bank, that is where the process begins. Banks have strict procedures for identifying banknotes that are no longer fit for circulation. These banknotes are inspected both manually and automatically using specialized machines that detect damage, wear, or counterfeit signs. Modern ATMs and cash dispensers are also equipped with sensors to detect worn-out banknotes. If a bill is found to be damaged or degraded, it is usually placed into special compartments or sent to sorting machines in banks. Once a sufficient number of old banknotes accumulate in banks, they are sent to the next stage, the Federal Reserve. These are special facilities located across the country that inspect, replace, and dispose of currency. Several such centers exist across the United States, strategically positioned to efficiently serve all regions. The process of transporting old banknotes to the Federal Reserve or specialized disposal facilities is strictly regulated. Banks typically work with security firms specializing in transporting large sums of money. Old banknotes are packed into special bags or containers that are sealed and secured against unauthorized access. This is crucial because even old money remains a potential target for theft or counterfeiting if not handled properly. Security guards or specialized couriers deliver these packages to the Federal Reserve or disposal facilities. The transport companies involved in this process operate under the highest security standards, and shipments are often escorted by police or other security services when necessary. You would not believe how many old banknotes accumulate each year, and this applies not only to US dollars, but also to other currencies. Bank vaults are not limitless in space, so from time to time, large batches of worn-out bills must be removed. Every day, thousands of banknotes pass through people's hands. Some get crumpled, some get coffee spilled on them, and some even end up in the laundry. Add the natural wear and tear, and you have a massive pile of money that is no longer usable. Imagine this. Every single day, the United States Federal Reserve destroys millions of banknotes. If you stacked them up, they would reach as high as a skyscraper. And that is just in one day. Transporting such massive amounts requires trucks. Money is packed into special bags or boxes. Each container has a unique number and seal to ensure it remains unopened. And while these may no longer be real money in a traditional sense, they still hold value. So the security of such shipments is incredibly tight. It is almost like a scene from an action movie. Armored trucks, armed guards, secret routes. Except here, instead of a heist, the mission is to get rid of this money forever. A true financial thriller, right? Before the old banknotes are destroyed, they go through careful inspection. Special systems determine whether they can be reused. If a banknote still retains at least 50% of its original form, it can be reintroduced into circulation after a special treatment, such as reprocessing or trimming. This significantly reduces the cost of printing new banknotes. Every year, an enormous amount of old dollars is destroyed in the United States. For example, in the year 2020, around 7 billion banknotes were eliminated because they were too worn out to remain in circulation. This process is continuously maintained at the highest level to keep the currency stable. Some damaged banknotes are not immediately burned. Instead, they are recycled into other materials, such as fibers that are later used to produce new banknotes. This helps reduce production costs and support sustainability efforts. There is also an interesting psychological aspect to this process. For many people, destroying money might seem like a loss of value, but in reality, It is part of a continuous cycle that helps preserve the stability and worth of the currency. That is why this process is just as crucial as printing new money. Old US dollars are often destroyed in specialized incinerators or through processes that ensure maximum material utilization. Banknotes are burned at temperatures of approximately 2,000 degrees Fahrenheit, completely obliterating them. Furthermore, advanced filtration and technology capture toxic gases and other harmful byproducts to ensure safety during the process. But does it not feel strange to burn so much money? Given how much we spend daily, these sums seem enormous. However, the portion of money that gets destroyed is actually a tiny fraction of the total circulating supply. In the end, the system is highly reliable and efficient. After the banknotes are burned, tons of ash remain. Some companies repurpose this ash into materials for making compost or even bricks. This part fascinates me. Dollars get reborn and continue serving humanity in new ways. This is one of the most expensive and complex machines ever built by humankind. Constructing it costs more than $3 billion and takes over 7 years to complete. It can dive to depths of more than 3,000 feet, remain submerged for months without surfacing, and launch missiles capable of altering the course of war. But how exactly is a nuclear submarine, an engineering masterpiece that remains nearly invisible even to the most advanced radars, built? Right now, you are about to witness this incredible process. A nuclear submarine is a highly sophisticated engineering marvel, and its creation begins long before the first sheet of metal ever touches the manufacturing tools. The initial designs are developed using advanced computer modeling software. At this stage, several critical parameters are considered, including hull dimensions and shape, power systems, weaponry, and noise reduction technologies. The length can range from 300 to 550 feet, directly impacting the submarine's diving depth based on its class. The most advanced submarines can descend to depths of 2,000 or even 2,500 feet, while some experimental models can go beyond 3,000 feet. Based on these initial designs, physical models of the submarine are constructed and tested in water tunnels. This allows engineers to analyze how the hull shape affects maneuverability, water resistance, and noise levels. Meanwhile, computer simulations help predict the submarine's behavior underwater at different speeds and during various maneuvers. Once all simulations confirm the calculations, the blueprints are sent to production. This is where theory turns into practice. Building nuclear submarines requires special materials capable of withstanding extreme pressure at great depths while providing corrosion resistance. Typically, high-grade steel or titanium alloys are used. Steel is more cost-effective and easier to manufacture, as it can endure high pressure and impacts. Titanium, on the other hand, offers superior strength, corrosion resistance, and non-magnetic properties, which reduce the risk of detection. However, titanium is more challenging to process and weld, as its melting point is significantly higher, approximately 3,034 degrees Fahrenheit, compared to steel's 2,500 degrees Fahrenheit. Before construction begins, all metal sheets undergo heat treatment, which involves heating, cooling, and applying special anti-corrosion coatings. The hull of a modern submarine is assembled from modular sections, simplifying the construction process. Metal sheets are cut with massive laser and plasma cutters, ensuring precision down to the millimeter. Each sheet is then shaped using hydraulic presses to achieve the desired curvature. Some parts of the hull feature spherical or cylindrical structures. The sections are assembled separately. These are massive rings, or compartments, that will be joined in the final stage. This modular approach allows different sections of the submarine to be worked on simultaneously, accelerating the overall construction timeline. Once all components are ready, the most critical phase begins: welding the hull. Welded seams must be exceptionally strong, as even a microscopic crack could lead to catastrophe at great depths. To meet all safety standards, automated electron beam welding is used, producing perfectly uniform seams. Additionally, every weld is inspected using ultrasonic scanners and X-rays. Most nuclear submarines feature a double hull design. The strong inner hull withstands deep-sea pressure, while the outer hull provides a streamlined shape, improving hydrodynamics and reducing detectability. Ballast tanks are often located between these hulls, allowing for buoyancy control. To keep the submarine as stealthy as possible, anti-sonar coatings are applied. These include noise-dampening polymer tiles that absorb sound waves, microporous composite materials that minimize the submarine's acoustic signature, and noise-reducing coatings for the propellers and power systems. Once all sections are ready, they are connected. Gigantic cranes transport the compartments into specialized docks, where they are bolted and welded together. The completed hull is then tested for air tightness by filling it with compressed air and checking for leaks. A structural integrity test is also conducted in a hydrostatic pressure chamber, simulating real deep-sea conditions. Once the submarine's hull is assembled and its strength verified, it is time to install its most crucial component, the nuclear reactor. This is the heart of the submarine, allowing it to stay submerged for months, or in some cases, even years. A nuclear reactor is more than just a machine. It is an entire energy system consisting of various auxiliary components that occupy a significant portion of the submarine. Modern nuclear submarines use reactors that function by heating water to generate steam. The nuclear fuel, typically enriched uranium-235 or uranium-238, is placed inside the reactor's core. As nuclear reactions occur, heat is produced, which then heats water in a closed-loop system. The resulting steam drives turbines that generate electricity and power the propeller. The reactor is transported in protective containers and installed using cranes through a designated hatch on the upper part of the hull. It is placed within a specialized compartment in the submarine's core, surrounded by radiation-blocking materials. This compartment is also equipped with emergency cooling systems and reinforced safety barriers. The reactor is mounted on a shock-absorbing platform that minimizes vibrations and impacts during submarine movement. Next, heat exchangers and steam generators are installed to ensure efficient coolant circulation, followed by the installation of turbines and electric generators, critical components for the submarine's overall operation. Finally, the compartment is sealed with multi-layered lead and composite panels to minimize radiation exposure to the crew. To ensure functionality, an initial test ignition of the reactor is performed. During this test, power levels are gradually increased, radiation levels in all compartments are measured, and cooling systems are tested under maximum loads. With the reactor in place, the submarine is still far from operational. At this point, it consists of empty corridors and compartments, so the next step involves installing control systems, life support mechanisms, weaponry, and crew quarters. Sonar systems are mounted in the bow and along the hull, enabling the detection of enemy vessels and underwater terrain mapping. The onboard computer system and automated combat control stations are integrated, ensuring precise maneuvering capabilities. Weapon systems are also installed. Torpedo tubes are positioned at the front, equipped with automated reload mechanisms for rapid firing. Strategic submarines are fitted with missile launch silos located in the central hull. Each silo is equipped with hydraulic locks and pressure control systems, allowing for missile launches at extreme depths. Considering that the crew can remain submerged for months without surfacing, nuclear submarines must be self-sufficient. They are equipped with oxygen generators, carbon dioxide removal systems, heating and ventilation mechanisms, and water reserves. Ever seen those tiny capsule hotels? Well, submarines have something very similar: sleeping capsules. They also feature dining areas stocked with provisions and a command center filled with control panels, maps, and communication devices. After the living quarters are fully equipped, the submarine is almost ready for deployment. But the most thrilling phase remains: a series of rigorous tests to prove that it can withstand immense pressure, stay undetectable, maneuver in extreme conditions, and perform combat missions. These tests can last anywhere from 6 months to 2 years, and include both factory trials and combat training for the crew. The submarine undergoes another airtightness test, followed by assessments of its electrical and navigation systems and a final reactor ignition. For the first time, the submarine leaves the shipyard and enters open waters. Stabilizers, hydraulic cylinders, and steering mechanisms are tested. Sharp turns, dives, emergency maneuvers, and maximum speed tests, typically 25 or 35 knots, are performed. The submarine then submerges to periscope depth, about 65 feet, to evaluate stability. At greater depths, ballast tanks are tested under load, and the submarine is gradually lowered to its maximum allowable depth, usually around 2,000 feet, depending on its class. Reactor performance under maximum load is also assessed. Once the submarine has proven its seaworthiness, combat systems are tested. Initial shots are fired using training torpedoes without warheads. Strategic submarines conduct the launch of a single ballistic missile, typically following a launch-dive-airburst trajectory. Tactical submarines perform test launches of Tomahawk missiles or similar weapons. The submarine also enters an area with hydroacoustic sensors, where specialists measure noise levels at various speeds and evaluate the effectiveness of its sound-absorbing rubber coating. Finally, the submarine undergoes a simulated combat mission, during which the crew must demonstrate full operational readiness. What if I told you that every bottle you throw away could live an infinite number of lives? Ardagh Group creates more than 160 million packaging units each year, using thousands of tons of recycled glass. Now imagine the scale: industrial crushers that process up to 3 tons of glass per hour, and furnaces working at full capacity to give this material a new life. What does this grand transformation look like? Keep watching. You will be amazed. The company participates in various programs aimed at reducing landfill waste, actively collaborating with municipalities and other organizations to collect and recycle glass. Through these efforts, Ardagh increases the proportion of cullet used in production, as reusing glass is more energy efficient than making new glass from raw materials. For example, the company supports deposit packaging systems, where consumers return used glass bottles for recycling. They also work with waste sorting centers, providing equipment to clean and prepare cullet for processing. In many countries, Ardagh funds community education programs to raise awareness about the importance of recycling glass. Through these initiatives, Ardagh Group not only minimizes landfill waste, but also significantly reduces production energy costs, as glass made from cullet melts at lower temperatures. This is an essential part of their sustainability strategy, focused on conserving natural resources and reducing environmental impact. Each year, the company produces over 160 million packaging units, highlighting its scale and importance in the global market. Thanks to advanced technologies and high manufacturing standards, Ardagh Group remains an industry leader, contributing to economic development and environmental responsibility. The story of Ardagh Group began in 1932 in Dublin, Ireland, when the company started as a small glass packaging manufacturer. Its founders aimed to meet the growing demand for glass bottles, driven by the expanding food and beverage industries. In its early years, the company produced bottles for local breweries and dairy businesses, gradually increasing its scale. A pivotal moment came with the strategic decision to expand through acquisitions. In the 1990s, the company began acquiring plants specializing in glass containers across Europe and beyond. It later entered the metal packaging sector, diversifying its business and tapping into new markets. Today, Ardagh Group is a global leader in packaging production. Its growth story is one of transforming from a small regional manufacturer into a world-renowned corporation that remains committed to its mission, creating high-quality, sustainable packaging that meets the needs of the modern world. Ardagh Group embraced the use of recycled glass as part of its commitment to addressing contemporary environmental challenges and economic trends. Glass is an ideal material for reuse, as it can be recycled an infinite number of times without losing quality. Over time, the company realized that transitioning to more sustainable production practices was not only an ethical necessity, but also a powerful business strategy. Several factors influenced this decision. First, growing demand from customers seeking eco-friendly packaging. In a world where more people are concerned about climate change and pollution, glass containers made from recycled materials have become an attractive solution for many brands. Second, economic benefits. Using recycled glass reduces energy costs. Melting cullet requires 30% less energy than producing new glass. This, in turn, lowers carbon emissions. Thus, using recycled glass has become a key part of their business, supported by both environmental and economic advantages. Garbage trucks deliver collected glass to specialized recycling facilities. There, it is first inspected to sort out materials unsuitable for recycling, such as ceramics, plastic, or metal. Next, the glass is crushed into cullet, small pieces that are easier to melt and clean. This cullet is then transported to glass manufacturing plants, where it is used as raw material for producing new bottles, jars, or other glass containers. The glass arriving at the recycling plant is initially inspected and sorted. Automated systems or manual processes remove foreign materials, plastic, metal, paper, or ceramics, that could disrupt further processing. The company employs approximately 20,000 workers globally. Before crushing, the glass is washed. Powerful systems rinse away dirt, labels, and product residues. High-pressure water jets remove everything: dried ketchup, wine remnants, stuck on labels, and even tiny bits of paper that seem impossible to clean off. This step is crucial for ensuring the purity of the raw material. Water streams splash everywhere as the glass passes through special brushes and rollers spinning at high speed, polishing each piece to a shine. The noise resembles a small waterfall storm. Watching clean, perfectly shiny glass emerge from the machines is a spectacle, transforming what was once dirty and labeled into something pristine. It feels like magic, but it is actually cutting-edge technology at its best. The cleaned glass moves into specialized crushers. There, it is ground into small particles using powerful mechanical hammers or rollers, resulting in fragments ranging from a few millimeters to several centimeters. This material, known as cullet, resembles gravel. Industrial hammer crushers can process up to 3 tons of material per hour. To remove any remaining foreign materials, the cullet passes through magnetic separators for metals and air jets for plastic and paper. Additionally, laser or optical scanners automatically sort the glass by color into clear, green, and amber categories. Sorting glass by color is not merely an aesthetic choice, but a critical technological process with several practical benefits. Colors affect the final quality and properties of the new product. For instance, clear glass is used for beverage or cosmetic bottles and must be kept as pure as possible. Green or amber glass, on the other hand, is ideal for packaging that protects contents from ultraviolet light, such as beer or wine. Color sorting is also essential for melting, as each glass type has unique temperature and chemical characteristics. Mixing colors can destabilize the process and risk producing defective batches. Mixed colors are harder to recycle. Such glass is often sent to lower priority uses or not reused at all, increasing waste. Properly sorted glass reduces energy consumption during recycling, as there is no need to clean the material of color impurities. Therefore, color sorting not only ensures the purity and quality of new glass, but also significantly reduces energy costs and maximizes the use of recycled resources. The finished cullet is stored in bins or bags and transported to glass manufacturing plants. Depending on the requirements, it is used as raw material for producing new glass. Though cullet appears sharp, storing it in bags is entirely feasible due to specialized materials. These bags, called big bags or flexible intermediate bulk container, are made of ultra-durable polypropylene with multiple layers that prevent tearing, even from sharp glass edges. Sometimes, the inner layer of big bags is additionally coated with laminated material for extra strength and dust resistance. The cullet, reduced to pieces ranging from a few millimeters to several centimeters, has edges that are less likely to puncture the bag material. Storing in such big bags is not only safe, but also highly convenient. The bags are easy to transport, stack, and dose for further use in furnaces. After preparation, the cullet is transported to Ardagh Group factories, where it is transformed into new glass products. A significant portion of the cullet is loaded onto trucks, either standard or specialized, depending on the volume and route. For larger shipments, even rail cars are used to cut transport costs and reduce the carbon footprint. Upon arrival at the factory, the cullet undergoes another inspection. This ensures that the material meets all requirements, such as the absence of any foreign impurities or pieces of the wrong color. Afterward, it is fed into melting furnaces, advancing the recycling process to the next level. Incidentally, the closer recycling plants are to manufacturing facilities, the more economically and environmentally efficient the entire chain operates. This is another reason why Ardagh Group actively supports local glass collection and recycling systems. Imagine a place where the trains of the future are born every single day, a place that brings together innovation, sustainability, and history. The Siemens Mobility Factory in Sacramento is over 2 million square feet of manufacturing space, creating the locomotives that move America. Here, one of the largest 3D printers in the world is installed, and up to 80% of the energy comes from solar panels. Curious about how trains are tested? They are run on specialized tracks to evaluate speed, noise, and stability. This is not just a factory, it is a true innovation lab. The story of this factory began back in 1984, when Siemens decided to invest in the future of rail transport in the United States. But they needed more than just technology. They needed a reliable base, and Sacramento was the perfect choice. What does the capital of California have to do with train manufacturing? Actually, the location choice was very strategic. Sacramento has a long history of railroad infrastructure. As far back as the 19th century, this city was one of the key hubs of the Transcontinental Railroad. In other words, the railway spirit has been alive here for over 150 years. Additionally, the region had access to a large number of skilled workers who could contribute to manufacturing. On top of that, the proximity to ports and other transportation hubs in California ensured smooth logistics. When the factory first opened, it was relatively small. Siemens Mobility was just beginning to build its brand in the United States. Initially, the factory specialized in manufacturing locomotives and trams. However, the company's ambitions were massive. They saw the need for modernizing American rail transport and decided to become part of this revolution. Within just a few years, the factory began scaling up production while implementing cutting-edge technologies. Over time, it started producing trains that you can now see in dozens of American cities. The Siemens Mobility Factory continued to grow. In the 2000s, it began producing modern high-speed trains and electric trains that meet the highest standards of comfort and energy efficiency. One of the key milestones was the expansion of the manufacturing facilities. The factory grew to over 200,000 square meters. This allowed for increased production capacity, the addition of new car manufacturing lines, and even testing grounds. Today, the Siemens factory in Sacramento is one of the most sustainable manufacturing sites in the world. Approximately 80% of its energy comes from on-site solar panels. Water usage is maximized for efficiency, and nearly all material waste is recycled. By the way, this factory produces trains for Amtrak, Brightline, and various urban rail systems, including the Los Angeles Metro and Minneapolis streetcars. The factory emphasizes localization. About 90% of the materials used in train manufacturing are supplied by American companies. This not only reduces logistics costs, but also supports the local economy, enables quicker responses to market needs, and ensures that the products meet client requirements. Siemens Mobility does not stop innovating. They are already working on trains with hydrogen engines and autonomous driving systems. While specific statistics on these projects may be limited due to commercial confidentiality, it is known that the company invests significant resources in research and development in these areas. So, how are trains made? It all starts with large sheets of aluminum and steel, which are cut and formed into components for train cars. And you know what? I was amazed by how organized the process is. Even at the stage where you are just looking at pieces of metal, Everything is planned down to the smallest detail. Assembling a single car can take weeks, and an entire train, months. But the result is worth it. Will arrive at the factory, they are immediately distributed into zones based on what will be made from them. Walls, floors, roofs, or smaller components. This is not just a pile of metal. It is all sorted and labeled with special codes. This ensures that no piece gets lost and that production does not halt due to confusion. The metal is cut on specialized machines that use lasers or plasma cutting, and there is no room for error. Every piece is cut with millimeter precision. But here is the interesting part. There is almost no waste. Leftover pieces are reused to create smaller components or sent for recycling. This is not just cost-saving, it is sustainable. The metal is used, for instance, to create train car exteriors. These are made of aluminum for a good reason. This material is both lightweight and strong, making it ideal for high-speed trains. I was even told that it is environmentally friendly. Aluminum can be recycled almost infinitely. Impressive, right? Cutting robots and hydraulic presses create parts that undergo further processing. Everything here is ultra-precise. There is no eyeballing it. In the next workshop, the train's frame is welded. Once the car bodies are ready, robots and highly skilled workers step in. I watched as each part was installed one by one, from roofs to floors, from walls to doors. It is like a massive Lego set, but on a scale you can hardly imagine. In this workshop, the car frame is born. Every weld is checked to ensure it can withstand future loads. Imagine sparks, bright lights, and sounds like in a blacksmith shop, but with robots. Workers install windows, doors, seats, electrical systems, ventilation, everything that makes a train comfortable for passengers. Next, the train is painted with weather-resistant paint. And yes, everything here is as eco-friendly as possible. Filters capture harmful substances to prevent environmental damage. But the most fascinating part starts with the details. Did you know that every train car interior is essentially a small universe? Wiring, control systems, air conditioning, seats, everything is installed with meticulous precision. One worker even joked, "Every single screw here is worth its weight in gold." Another thing that amazed me was how many processes are automated. For example, electronics inside the cars are tested using special simulators. It is like a video game where the system checks if all buttons, displays, and even Wi-Fi are working. Now picture this. Before a train hits the tracks, it is tested on a special track. Yes, they literally run it here to measure speed, stability, and even noise levels. Watching this giant accelerate is a whole new level of satisfaction. Here is what makes factories like Siemens Mobility special. Everything works in harmony. On one hand, there are people working with their hands, putting a piece of themselves into every car. On the other hand, there are robots and automated systems making the process faster and more precise. I was even shown one of the largest 3D printers in the world, which prints train parts. Imagine this. Instead of waiting for parts to be delivered from across the globe, the factory can make them right here, right now. It is not only convenient, but also eco-friendly. Less transportation means fewer emissions. For instance, the 3D printer produces mounting nodes, frame elements, and even special ventilation components. Traditionally, these would need to be cast or welded. But here everything is done more precisely, faster, and more efficiently. Fairings, structural components, interior details, spare parts, and prototype versions of parts can all be printed, saving materials and time. Okay, some might ask, what is so special about this? Trains are just trains. But no, each of these modern cars is a step forward in transportation development. More sustainable materials, energy-efficient systems, passenger comfort, all of this impacts not just us, but the future of our planet. Moreover, factories like the one in Sacramento create jobs and introduce new technologies that can later be applied in other industries. It is a place where technology and people come together to create something truly remarkable. Oh, you cannot even imagine how massive this factory is. The Siemens Mobility facility in Sacramento spans approximately 2 million square feet. Picture several football fields connected into one giant structure. It is a city within itself. Workshops, conveyors, rail tracks, repair shops, and even test tracks for finished trains. The factory is divided into several zones, each responsible for a specific stage of production. When I left the factory, I felt like I had visited the future. This is a place where innovation, craftsmanship, and human talent combine. If you ever get a chance to visit something like this, do not miss it. It is truly impressive and changes how you see the world. So, are you ready to hop on a train next time and think, how was this made?